I'd like to introduce our speaker for today, Professor Uhao. Thank you.
Thanks, everybody. I'm going to try and summon as much energy as I can this morning, since, well, things didn't go, I don't know, my way. I'm sure many of our ways yesterday. But I'm excited to be here. Yeah, I was all prepared to do my own introduction, so that's nice. Thank you for that, Carlos. I'm actually just happy to be here in the College of Education finally. So, my 25% appointment here ends up sometimes like not, feeling like I really get to be here and invest in all the people that I like being around. Not that school computing is, bad or anything like that, but it's a different crowd, different kind of energy. But anyway, yeah, I'm happy to be here. And so I'm going to share today just some of the current research that I'm working on in the College of Science and Math. And also prior to that, I'm going to show a little bit about what I've done in the past, just to kind of give a preface of what it is. So am I in your way when I'm here? I apologize. Okay, okay. Okay. Which one do I press? I'm going to press every button on the tool, as well as some of the augmented reality, mixed reality stuff that's out there. Ways of basically visualizing concepts digitally hold a lot of promise in terms of helping students with these kinds of things. This was supposed to be, anyway, this was a video of a lab, a virtual reality lab that I created. And the idea was to basically help students have these experiences of doing science experiments if they didn't have access to the sort of typical chemistry lab equipment and things like that. And the idea here, again, was to actually not necessarily look at the abstract concepts that students could be learning in this way, but Joe, help me. But anyway, the idea was, okay, I don't know where that thing is now. The idea was basically, I didn't touch anything, I swear. I have not touched a single button on this thing yet. The idea was to look at how students would behave in a virtual environment. Like when they're in a virtual lab, do they actually wear safety equipment? Do they engage in like cleanup activities at the end? Do they just like run around and try and throw things, because they can? Stuff like that is what I was looking at. And so anyway, that was one half of this kind of experience that I was trying to study. And then, yeah. It's weird. It is on. Okay. I think I can forward and, yeah, go forward and back. This is a video. So I don't know why the video doesn't play. Because it was embedded in it? I don't know. You hit forward. Wow. Yeah. You're gonna have to sit back here now. But anyway, so part of the lab experience thing was actually I wanted to see, as well as we were talking about how to try and help students visualize abstract concepts. There's this molecular world experience that I created for them, where they could sort of be zoomed into a life-size experience where atoms and molecules were at the same size as them, and then they could interact with them. They could bring them together to connect. They could pull apart certain molecules if they had the right ones together. And the idea was to give them a really active learning experience, utilizing virtual reality. Okay, that's okay. Yeah, okay, don't worry about it then. That's okay. But one of the most important things also that I wanted to look at here was actually when we combine these two experiences. So yes. So when they were doing the lab, then I would have the lab experience, and this is something that we being in virtual reality actually afforded us was that when the chemical reaction occurred, then I could zoom them into the life-size beaker experience and then have them look at the molecular world. And hopefully they would make the connection between sort of the macroscopic things that they were learning in the lab with the microscopic sort of foundations of chemistry that are often really hard to visualize. So from this was previous work. From this, some people may think, why involve virtual reality at all? Like, why not use the same manipulatives, things that I used when I was learning as a kid, right? Like the ball and stick models made of plastic and wood, which are totally effective and they're good too. I'm not going to say they're like not actually effective things to use, but one of the helpful things is that virtual reality provides all these sort of immersive learning experience benefits. Like for instance, they provide a narrative that can make content easier, right? Even if it's not like a really super well-developed story that you're trying to create for them, just the fact that they're in this kind of immersive experience lends a context to what they're learning, and then provides a more interesting and motivational kind of experience for them. Active learning experiences, again, just they don't have to be passive in that kind of experience, right? They have the control of where they look, of what they're sort of moving around in, and so as a result, they have more agency in it, and that also lends itself to a more effective learning experience. And then finally, down here, it can be an experiential learning environment where immediate and concrete experiences provide a basis for learning. And so again, this is one of the things that was really important to me, is that we give them a concrete experience where these things that are normally just sort of imaginary, hard to visualize, gives them a concrete, a physical experience that they can actually sort of connect to that concept, and then therefore help it to be remembered better, and hopefully they learn it better. All right, so my colleague Thomas Mueller, who I'm going to share about our current work that we're doing together. He's in the biology department. I asked him to send me a slide describing the class that we're cooperating with. So this is the slide he sent, and so I'm showing you this. This is not my style, but I was like, this guy's got to be a brain guy, because I don't know what is going on here. But yeah, good. I'm glad. Yeah. The class that I'm cooperating with him on is Bio 319, which is basically the sort of beginnings of neuroscience for students. He titles it The Quest of Understanding the Neural Basis of Human Behavior. And so really what he's trying to do is look at how human behavior comes from and is represented in sort of the brain's functions and the different structures of the brain. All right. And so as you can imagine, it's hard stuff to kind of like visualize, right? It's hard for us to visualize what's happening inside of our brain, even where all the different parts are and how they interact with each other. So I was thinking, oh, this would be perfect for some kind of virtual, visualization thing. I guess that was supposed to be a picture of him, and I was like, this doesn't look like you at all. So I took this from the Montclair faculty. I was like, Thomas, let's give him at least who you are. He's a great guy. He's usually more excited than this. I don't know why. But anyway, just real quick about the class. So again, we talked about how it's focused on teaching students about the connection between behavior and the brain. And so it looks at things like dopamine pathways. How do your emotions, are they represented physically, like in the brain, in terms of like where hormones and things go? And then also it is based off of basically looking at brain evolution. And so in his class, the students look at, what are those things? Planaria, and they cut them up and then they actually grow like two heads and things like that. And then also, we're actually working on like a side project where we're trying to 3D model a zebrafish brain, which is like a small fish that a lot of biology researchers use, I guess, like because it's easy to see. Anyway, so the background for kind of our work here is that biology is a great example of a STEM subject that has lots of abstract concepts, things that are hard to see, especially when you think about sort of pathways and how things just go, move about in the brain and stuff like that. And so it's one of those areas where, again, biology students, especially neuroscience students, they need to know this stuff because it's foundational, but it's often, again, could be a sticking point for some of them. Like if a student's really interested in studying neuroscience, but then they get stuck on this like very, first step sort of in the process, then that stops them from continuing. And we want to encourage as many people again as possible. So we're trying to make it accessible. And then also, Thomas even said, he's like, I want to have a way to sort of dynamically teach this course. Brains are sometimes not that exciting. It's just like a blob that just sits there. How do we make this more exciting for students? And then I was like, well, we can animate it visually in virtual reality. So before I go into that, though, again, just some theory that it sort of builds the foundation between why or on why virtual reality, augmented reality, all these immersive learning contexts are helpful for learning. So embodied cognition is one of the cognitive theories that really supports learning through virtual reality. It's a cognitive theory stating that basically human cognition or human knowledge is a product of not just your brain, but also your body and your actions in the world, the context that you live in. They're all integral in building the knowledge that we know, okay, and the knowledge that we use. Grounded cognition is similar, but it focuses more on actual grounded, how our context, how our knowledge is built upon these grounded either simulations or things, concrete and physical experiences that we have that relate basically to abstract concepts. So we like things that maybe don't have a physical or concrete experience, we automatically sort of relate those to something that we do have physical experiences with. And then also sometimes if you're just having like a sort of non-physical kind of idea, we automatically relate that to a physical experience that we once had, right? Like the example that is often seen is the idea of grasping activates the same neurons in your mind that activate when you actually physically grasp something, okay? Even though you may not be doing it, they activate the same neurons, okay? Anyway, Kolb's experiential learning basically gives a framework for how students learn through experiences that are transformative and they're excellent learning experiences. Of course, I get a phone call right now. And then finally, the cognitive affective model of immersive learning. This is a kind of VR specific learning theory. Basically, it outlines just the concepts or the different affordances that are unique to VR and how they can relate to learning experiences. All right, so the research questions that we were interested in looking at. The first one is kind of like the main one that we're going to talk about today. The second one is something that actually we're kind of actively looking into. And then third one is sort of like a, in the future, hopefully we can build something for that. But first one, how does the VR brain intervention affect the learning experience of Bio 319 students? So this is the study that I'll be talking about today. 2, if an immersive VR brain experience is available for neuroscience students to study with, will they voluntarily use it? So we actually have, I don't know how many headsets they have here in the ADP Center. They have like, I don't know, maybe 5 of these. And I've given them this biology VR brain app to actually load onto them. And then we told the Bio 319 students, hey, this is there in the ADP Center for you to use. Use it whenever you like. And then we're tracking basically how often, if people come, how often they come, and then how long they use it. And then third one, what does assessment look like for an immersive VR brain experience? So how can we do maybe assessment within this experience, like eye tracking or things like that? All right. So here's a timeline of when Thomas and I first started with this idea. This was in December of last year, all the way through till basically this most recent month. But we started with ideas. We just brainstormed about what he liked, what he wanted, what I could do as a developer in also being like a professor here. And then but we developed something that by March we were able to do a demo in his class. And so this was like the first sort of, we just had a 3D model. We showed them like, you could be in virtual reality, you can interact with this model. And then they actually gave us feedback like, oh, that looks really cool, but maybe you could show this or do that. And so I took it back, made some adjustments, Then we had them do like a lab class experience where they were in their lab class, and then we had 8 or 9 headsets. And so every student got to try the experience. And we had integrated some of the feedback that they had given us in terms of like maybe add false colors. I added a walkthrough brain where I made the brain huge, and then they could like physically kind of like look through it. I also put in a quiz. It was just sort of like a functional thing, like let's see if we can have a quiz in there, you know. And then they gave us feedback. Surprisingly, the number one feedback was the quiz only had 4 questions, and they were all like, "We want more quiz questions." And I was like, "Really? Like, when have I ever heard of a student wanting more quiz questions?" But I was like, "Oh, this is great. Okay, so you know, something about it really piqued their interest. They liked being in it. They were willing to like, sort of, you know, want to try and test their knowledge, which I thought was really interesting." So anyway, after that, I did another round of iterating, and then we had one more experience with them where we were in the lab class again. They tried out the changes, and we also had them do a survey to see how they felt about it. So that was last year. This year, over the summer, I did a little bit of changes just to make it more friendly for them in terms of like user interface stuff. We did do a class demo with his current class now because it's a new class of students. We wanted to see, again, we're going to try and sort of continually do this in his class. And then now down here, right, everyone can try it out. You all could actually try it out if you had time. And so, oh, sorry, there's some pictures. Okay, just real quick. So the methodology, again, the research question number 1 is the one that we were focusing on. How does a VR brain intervention affect the learning experience of Bio 319 students? Yeah, this is the class. There were 16 students that ended up taking our survey out of probably like 20, low 20s, 22, 23 students. It was design-based research methodology because, as you saw, there's a lot of iteration going on. There we go. Iteration, getting feedback, trying it out again, seeing how practically it could work in the classroom was a large part of what we wanted to do. And then we had our measure was a post-survey where it had Likert and open-ended questions. All right. So again, here's some pictures. Students, again, they're in a lab classroom. And again, we had like 8 or 9 headsets. So about half of the students were usually in VR, while the other half were not, and just kind of like sitting. And so one of the important things that we did was actually you can cast what the person in VR sees to another device. So we had devices set up for each VR headset so that students who were not in VR could still actually interact with the student who was and talk to them about like, oh, what are you looking at? What are you seeing? Have conversations about that. So as you can see, in each one of them, they had sort of a view of what the other person in virtual reality was looking at. Let's see. Here is, this was a good video. Okay, but anyway, this was a video of everyone kind of working with the VR headsets. The open spaces here were actually very helpful to have because obviously it gave space for students to stand. It was a little bit nerve-wracking at first because there are like glass cabinets, right? You're in a lab, there's like glassware just like sitting over the side. And so I was really nervous. Students would be like, flinging around. And I mean, the experience was not one of those like fling around kind of things. So I didn't have to worry too much about that. But it definitely, I mean, it could have been a different kind of environment, right? You don't have to do this in a lab classroom, obviously. And that's one of the benefits of doing some kind of thing with virtual reality. It does, however, I would say, put them in kind of like the right mentality. Like when you're in a lab classroom and then you're doing something on science, it's like there's some sort of that context, that environment kind of like puts them in the right mindset. And also one of the logistical things that we realized is that, again, there's 9 headsets here. Having other, like if it was just me trying to manage all this stuff, it's like too hard. You usually need to have help because there's logistical issues with like headsets. People press the wrong button, they don't know where they are. And so I often had at least 2, maybe 3 students from my lab helping me out, like this girl right here, Lourdes. She was very helpful. But in terms of like utilizing this kind of technology in a classroom, it's really helpful to have more than one set of hands, especially as, you know, someone who's trying to like sort of lead and oversee everything. It's helpful to have people just like troubleshooting stuff. I was going to do a demonstration. I might do it later. We'll see how much time we have. Okay, so the result of our survey. The first question we had, was it helpful in teaching me something new about the brain? Again, most people strongly agreed. And so we were, you know, happy about that. In terms of increasing their interest about learning about the brain, again, similarly, most students were interested in it. They liked it. And these are students who are already probably interested in the brain stuff too. So you're factoring that part in. But it was good. It showed that it was able to motivate them. It was interesting to them. Again, this is probably like the third time that they had used it. So I mean, the novelty effect could still be there, but it's at least a little less than if it was like the first time, right, that they used it. We asked them, was it a good use of their academic class time? Because I did notice, and there was one girl actually who pointed this question out. She was like, "Why are we doing this? This just looks like playing." And I was like, "Yeah, it is like playing, but it's like educational playing. You know, the things that you're doing, you are actually learning stuff." And most of them agreed. They thought that, you know, even though this looks like a thing you just play games on or just for entertainment purposes, they thought that actually they learned a lot and they enjoyed using it in their classroom. So, and then also we asked them, you know, would you like to use it outside of class time? And again, most of them said yes. And so then that's sort of the impetus for what we wanted to research was like, oh, really? Well, if you want, you say you want to use it outside of class time, will you actually go use it out of class time? So now it's available. And, you know, I haven't looked at any numbers that we have yet, but I'm very curious to see if they took the time and effort to actually, you know, come do that. Because it is a whole sort of different thing, you know. Some other results, we asked them, you know, did you learn anything new about the subject from this experience? What was helpful is that they said, yeah, it was like a good visual aid of the brain and where things are. I relearned about the structure of the brain, its characteristics. I was able to relearn the location, or sorry, learn about the location of the brain through pulling it apart and reconstructing it. I learned the visualization of some parts of the brain. I knew the functions, but sometimes it's hard for you to memorize how it looks, right? How it looks like. So it was good. The goal, we wanted to help students visualize things and help them to sort of get a better sense of what these things looked like and where they were. And we feel like, you know, that was achieved. And so even if the students, you know, at first didn't realize it, you know, some thought they were just playing something, but sort of what was good was that what came out of it was new visualizations of the brain, the different parts, things that they maybe didn't realize or know previously. What aspects of the VR Human Brain Time app do you think could be better? So of course, I wanted to see, you know, what things could we make better? What do students want to sort of look at differently? They wanted or they said the walkthrough brain can be overwhelming. All parts of the brain are literally all over you, and it's hard to actually see anything. And this is true. When I first made the walkthrough brain part, I basically just took the 3D model that we had and just scaled it up, and then like said, "Here, walk through it." And then what I realized later on, as I was doing myself, was like you actually need to you have to sort of stretch and make space in there for students to actually be able to see. Because I mean, even though it was more accurate to have it, you know, every piece of the brain be where it should be, it didn't lend itself to being easily sort of viewable. So in that aspect, I was like, okay, there's ways that design actually really plays a part in these kinds of things. And then other comments, more tech dummy friendly, please. I think the controls and the pointers could be better. It kept disconnecting. Maybe directions of use. So do you all, yeah, basically I did some changing with the controls, made it like labels on the hand so they know like, oh, this button, you know, is always doing this and that's that. So they could always just look at their hand and see what it meant. So the conclusions, students enjoyed using virtual reality, and that's not totally like mind-boggling. It's like probably they would, right? But increased their interest about the human brain, which was good. And what was important too is that it was helpful for visualization of the different parts of the brain. So students also then recommended it for other aspects. And again, these were neuroscience students, so all of their recommendations were like biology related, anatomy, chemistry, cell biology. But again, in the sciences, there's lots of different things that you could represent in this kind of experience that I think would be helpful. And then other sort of design things and logistical implementation things that we learned, close and frequent collaboration between the developer and the instructor is really important, because we were constantly looking at things and saying, oh, this works well, this doesn't work well, and having to change it. So if other people are interested in ever trying to sort of implement this kind of idea in a classroom, which I highly recommend, but again, it takes a good amount of collaboration between the professors or developer professors, whoever they are. And then also last point, repeated exposure can help limit logistical issues and maximize learning time for students. So what was helpful about this was that we didn't do just like a one-time thing and then just leave it at that, right? But as we successively went into the classroom, students became more familiar with it and comfortable with it, and then were able to more quickly sort of like get into the experience, try things out, look at the things that were different, and then also actually give feedback too. Because in the beginning, they didn't know what it was capable of, right? But as they got used to the technology, then they're like, oh, this would be great if I could do this, or if I could hear that, or that kind of thing. So, and by the third time, they really became a part of the creative design process for us. And I think that was also really helpful, both in getting sort of their, their ownership, let's say, of it, as well as them seeing it as an effective tool. So future work, right now, I and some students are working on creating a multiplayer experience where more than one person can actually be in the virtual space together. So you could like throw brain pieces at each other if you wanted to, just to make it more fun. You know, it's like socialized learning in a way. But we're trying to prepare for next fall because you won't be teaching the class in the spring. So hopefully by next fall, we'll have some of these things ready. And I'd love to share it with you all if, comes around to that. And then we're also trying, hopefully by the time we'll also get ready a semester-long pre-post test educational outcomes measure. Yeah, so that's it. Thank you for coming.